All right. Let's see what we got here today. I'm in a little trouble. There it is. Lesson 23, people. Volume, 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 volume. All right. Now, what we're focusing on here today is everything that deals with a right prism. All right. A right prism. So that's what we want to look at. Our focus is going to be. So, big thing here is what's the volume of the right prism on the right? Well, the whole idea here is volume is all about how many cubes to fill a shape. All right, that's the general idea of what volume is. Area is how many squares it takes to fill in a shape. All right, so area is for two-dimensional shapes. Volume is how many cubes we end up filling in a three-dimensional shape. So if we kind of look at our cubes here, we got, okay, it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 times 6. All right, yeah, there's 36. So your volume, so it's 36 cubes that we're looking at here. So the other way we can look at it here is by our label, we can say 36. We don't know what to measure, so it's units and then cubed. And again, it's cubed because we want to know how many cubes to fill it in. Area is squared because for area, we want to know how many squares it takes up. So formula-wise here, a lot of people are just like, yay, length times width times height. Well, okay, yeah, that's for a rectangular prism, and that's it. So that's not the formula that we endorse here for any sort of a prism here. Any sort of a prism. We call them right prisms because they actually form right angles at the base. They're not slanted off to the side. So for any sort of right prisms, we use this. All right, and this isn't base. All right, it's a capital B here. So this is the area, all right, of the base, and then we multiply it times the height of the prism. So this one form is going to work for all of our right prisms. Just kind of what you see in prisms there. So that's what we want to be using. So let's see what we got here. Let's see what happens. All right, so label it in there for it there. You got a height of 4. All right, so put a 4 in there. The length of 3, width of 2. So width typically goes left to right, although remember it's not going to make a difference because you can turn it. And this is why a lot of people fall in love with length times width times height. But again, we want something that's going to work for all of our prisms. So area of the base, if we look at the base here, all right, the base is a rectangle, so that's why you're going to do the 2 times 3, and then multiply times the height, which is your 4. So yeah, I mean, could you just realize that a right rectangular prism is length times width times height? Hey, it works, but remember, it only works in this one particular situation. We don't have any sort of measurements here, so we're going to go with 24, and then it's going to be units, and then cubed. All right. So let's see what we got here. Let's go ahead and let's just do one of these. We'll skip this guy for right now. Again, volume here. Volume is the base times the height. So the area of the base. Now again, I always use the base as what would fit into the palm of your hand. And so if we were to pick it up, that's where the base would be, is right there. So we're going to find the area of the base. So we'll do 11 times 5, and then the height. All right, that's times your 6. Do a little bit multiplication here. I'll do 5 times 6, get 30. 30 times 11, all right, 330. All right, and now we're at centimeters, and then we're at cubed. So again, stuff that you probably have come across before, if not a huge issue, but this is the reason why we like this formula of the area of the base times the height, because we can work with all of our prisms. If you just memorize length times width times height, that works for one situation, for one particular problem. This way, we can make this connection, all right, and take it from there. So what kind of shape we got here? What is it? Yeah, it's a triangular prism. So it's just that someone's kind of tilted it over a little bit there because we have the 2 triangles for your bases. So area of the base, well, it's a triangle. How do you find the area of a triangle? Well, it's 1/2 times the base times the height. Now, here's the thing, all right, is this height, all right, the exact same as this height? I'm wrapping this in parentheses so we can show it's coming from here. No, remember, this is the height of the prism. This is just the height of that particular base there. So as we saw from before, sometimes it's easier to draw the base out so you can see what you're using here. So that's a 4, and then that telling you that is a 1/2 right there. We can see that forms the right angle, what we're looking at there. So 1/2 of the base times the height. So a 1/2 times 4 times, and then a half here, and then the height of the actual prism. Yeah, remember the height actually connects the two bases together, so it's a 6.5. So again, visualizing here, you just can't grab numbers. You have to visualize the shape you're looking at here. So let's see here, half of 4 is 2, half of 2 is 1, and then 1 times 6.5. Yeah, there you go, 6.5. We're done with it. That's it. All right, 6.5 meters and then cubed. So again, area of the base times the heights. It's a triangle for the base, so that's why I'm using this now. So again, it's not always length times width times height. That's only for one particular shape. So hey, let's see what happens here. All right, volume is area of the base times the height. You can see I'm always forming it down first. It's a nice little routine to get into. It keeps me focused because there's just so many numbers that are going around. All right, the big thing here is organization. Yeah, I know it doesn't make me happy at times as well too when I have to clean my room and be organized. But for this, it works. So, okay, area of the base times the height. The base, once again, is a triangular prism. We can see our triangles there. All right. So that's what my base is. So there's the 16, there's the 12, there's the 20. So if I want to find the area of this triangle, I'm going to do 1/2 times the base times the height. All right, so, and then I need to multiply it times the actual height of the prism. So 1/2 times base and height always meet at the right angle. All right, so I do need to use my 16 and my 12. So times 12 times 16, and then I need the height of the actual prism. So I'm going to go back to the picture here. The height of the actual prism is, yeah, it's 10. It's 10 there because, again, it's connecting the two bases that are there. So let's see here. 1/2 of 12 is 6. You need to do then 16 times 6. Now, this is right like, 16. Let me do that. 1/2 of 16 is 8. Yeah, 8 times 12. That's a little bit easier to do maybe for your mental math. Or, again, you can just reach for your calculator and just punch it all in at once. This should give you 96. 96 times 10, 960, and then centimeters, and then cubed. So, again, area of the base times the height, that'll get you to move on with it. So, okay, so this is the ones that we're kind of after because, again, organization breaks things up into pieces. These are the ones that we want to make sure we're comfortable with here. So we are finding volume here. The big thing here is like what we saw with the area of our composite shapes. You had to break them up into smaller ones. So this time we're going to break it up into 2 smaller ones there, find the volume of each, and then combine it. So the big thing here is, do you see the triangular prism? All right, sitting on top of the rectangular prism. All right, so this is kind of like our plan of attack here. So let's see what we can do here. The triangular prism. So I'm going to do area of the base times the height. Let's see what we've got here. What do you think here? What do you think for area of the base? All right, what do you see in there? Do you see the triangle there? All right, do you see the triangle? Okay, so there's the half right there. How wide is this going from left to right? What's the base? There it is. Yeah, it's a 4 that's there. So yeah, it's a 1/2 times 4 and then times a half, because remember it's 1/2 times the base times the height, and then the height of the actual prism. So the height of the actual prism here, remember, it connects the 2 triangles together, so that's the actual height of it, and that's a 6.5. So times 6.5. There's almost like we've seen that before somewhere, huh? Is it? Yeah. All right. And I'm gonna go ahead and keep finishing this off. I could move on and then type it all in my calculator at once. That's just a little dangerous, a little too much typing at once. So I'm going to break it up into chunks. 1/2 of 4 is 2. 2 times 1/2 is 1. 1 times, yeah, there you go. Yeah, hopefully you've seen that before. And now we're going to add on that rectangular prism. So again, area of the base times the height. So your base here is your rectangle that you're dealing with. So I am going to do 4 times 6.5. And then I need to multiply times the height of the actual prism. And again, the height connects the 2 bases there. So that's why I'm going to choose 6.5. So I'm going to reach for my calculator here. I'm just going to punch them in as decimals. That'll be fine. Oops, not 65. Like I said, always watch your screen. It's amazing how many times you just type in something incorrectly. Let's see here. So we add that to get that. We'll add it on. And again, nothing too dangerous here. work-wise, from a number standpoint, coming out to be pretty clean, pretty crisp. Again, it's your organization, all right, and that's what we're after here. So keep in mind, area of the base times the height for any sort of our right prisms. If we use that and we don't just fall in love with length times width times height, we're going to be, we should be just fine. That's it, people.